Right, the Chapter 2 practice test, you should have already completed the test before looking at this video, or be working a problem, watching the video, pausing, and working a problem at a time. Right, so lots of calculator work and some graphing stuff. For this first one, we're asked to find y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. In part B, make a table of values that includes the vertex, and then use this information to graph the function. Right, so we have x squared minus 8x plus 15. We're going to plug that right into our equation editor. X squared minus 8x plus 15. I peek. I'm going to hit graph, get a little picture of what we're looking at, and then I'm going to go to table. Okay, so here we are looking for vertex. Vertex is that spot where we see symmetry in the data, right here. So, right, I see 1, 8, 7, 8, 2, 3, 6, 3, right? This point right here does not have a match. So that is going to be my vertex, right? So I'm going to plug that in right now. Vertex of 4, -1, right? 4, -1. Okay, that is also my axis of symmetry, x equals 4. So rest of my data for my table comes right out of the table on the calculator. 3, 0, 5, 0, and 2, 3, and 6, 3. Right? I talk a lot about symmetry in the data. Right? These 2 points have a match. These 2 points have a match. This point right here has no match. That's my vertex. So I'm going to graph that up. 4, -1, and then 3, 0, 5, 0, and then 2, 3. I'm off on my graph. So I'm going to graph that up. 4, -1. And then I graph 3, 0, 5, 0, 6, 3, 2, 3. Right? There's my graph. That whole concept of axis of symmetry, right? The fold line on which the graph would be symmetrical. It goes right through the vertex. We're not asked to graph that, but it's right there. Okay, so that is what we need for number 1. Number 2, more of the same. New equation or function is going to go in. Clear out the old. 2x squared minus 4x plus 3. Always give it a quick look. Make sure that you have typed everything in correctly. Peek if you want to. I see, oh, it doesn't even come down and touch the x-axis, right? So I'm going to get my table of values going here. Right, I'm looking, I'm scrolling in the data to find where the data is symmetrical. Right, I see that vertex on my table of 1, 1. Right, that's the point that has no match. And then I see 0, 3, 2, 3. And then I have points again at -1, 9, and 3, 9. So then I'm going to use these points to go ahead and graph my data. Right, I get them all plotted out here. And then I'm going to do my best to connect them with a nice smooth parabola. I see then that I have an axis of symmetry, an axis of symmetry at x equals 1. And it's always the x value of the vertex, and it's what splits the graph in half, as we see right here with this blue line. Looking at these next 2 problems, finding if each graph has a minimum, maximum value, and then stating the vertex. And then we're also asked to state the domain and range of the function. And so the best way to do this is going to be just to plug this into our graphing calculator, right? So whether you're using your TI or Desmos, that's really up to you. I'm going to go ahead and get this typed in. Give it a quick look, make sure that everything matches and that I've typed it in correctly. And then I'm going to take a peek at the graph, right? I see that it has that minimum value, the low spot in the roller coaster. And I might be able to get that off of the graph itself. If I'm in Desmos, I certainly can tap on and find it. But I see it has that minimum value. I'm going to go to my table of values then to try and locate that vertex. Again, I'm looking for a spot, piece of data that doesn't have a match. So the -1 produces -9, and it does not have a match. The others have matches, right? The -8 y values have a match. The -5 y values have a match. So that -1, -9 is going to be the vertex of this graph. If I needed to graph, then I could use this data, but I don't need to. I do need to state the domain and range, right? So domain is always going to be all real numbers for these quadratic equations, right? They go from -infinity to +infinity. So I can write all real numbers, or I can write the inequality. I would just leave all real numbers. To me, it's easier to write down. But the inequality then would be -infinity is less than x, which is less than infinity. Range, right? I have that low spot in the data. It's a minimum. So that -9 is going to be the lowest that my y value can go. So I am going to write that as an inequality. I'm going to say that y is less than or equal to, or correction, y is greater than or equal to -9, right? I see on my screen that I get that low point there. So y is everything bigger or equal to the -9. For number 4, I'm going to clear out my old data. I'm going to type in my new equation. -x² plus 14x minus 5. Glance at it, make sure that I typed it in correctly. Go ahead and hit graph and get an idea of what you're looking for. I don't get a very good picture here. I can always try to go to adjust my zoom. Zoom 0 gives me zoom fit. Sometimes that works very well, and other times it does not work very well at all. So at this point, you may be best going to Desmos and trying that. We do see a little bit of the arching shape there. We see that vertex starting to take shape. I see it does have a maximum value. Kind of hard to see, though, what that maximum value is from the graph. So I'm probably going to go to table to try and get the max value. I'm going to scroll down looking for that symmetry in the data. I'm seeing the data start to get closer together, and I see right here the 7, 44. That 44 does not have a match in the data. I see 43 on each side of it. I see 40 on each side, right? But I see that vertex at 7, 44. Putting some parentheses around it to indicate it's an ordered pair. Looking at domain, always all real numbers. So I'm going to head and get that written down. And then looking at range, because it has a maximum, right? Everything is going to be below that point, right? As I'm scrolling along, I see numbers less than 44, and then it comes to a peak right there at that vertex. 44 is going to be my highest point. So y is everything less than or equal to the 44. Looking at 5 and 6, those are just determining the solutions, looking at the graph, telling where that graph crosses the x-axis. Number 5, it's pretty obvious. They've even highlighted the points there. They've got them marked out right where they cross the x-axis. Right, so I see these 2 points right here at x equals -1 and x equals +1. So I'm going to say x equals -1 and 1. For number 6, it never crosses this axis line, right? It drops down, but it never touches. So I'm going to just say that one has no solution. Looking at number 7, given the equation but no graph. So I'm going to type that into my y equals the negative 2x squared minus 6x plus 5. And then I'm going to check and make sure I've typed it in correctly. My problem is going to be I've adjusted the zoom. So zoom 6 gives me that original 10 by 10 graph that I'm used to. So I see that I have that maximum value there, but all I'm really asked to do is find those roots where it crosses the x-axis. I see on the graph, though, that they are not going to be integers, right? It's not going to be a nice friendly number. It's going to be a decimal. We could use the calculator tools to find that, but we are told in the instructions to find the consecutive integers between which they're located. So I'm looking for where that graph switches from positive to negative in the table, right? So at 0, it's +5. At 1, it's -3. So I know that that first root is going to be between that 0 and 1, right? So I'm looking for a change in sign on my output, on my y values. And I'm going to scroll around, try to find if it has another one. I know from the picture that it does, right? So again, I see between -3 and -4, that sign change. So those are my 2 roots for number 7. For number 8, I'm typing this in again, x squared plus 10x plus 24. That's going to give me my equation. I'm going to type it in, check it over, make sure that I typed it in correctly, and then I'm going to peek at the graph. And I see possibly 2 integer values, right? So I'm going to go to table, and I'm looking for those outputs of 0. And so I happen to be right there at the first one, -4, 0, and -6, 0. That makes for a nice, easy graph. So I'm going to say I see from my table there at -6 and -4. I'm going to plot those points on the graph, right, at -4 and -6, and I'll just throw the vertex on there at -5, -1, and then connect them with a nice smooth parabola shape. Right, looking at the next problem, right, that AHK. So I know that y equals a times x minus h squared, and then plus k. So that negative h in there, really, we really need to pay attention to that because my h value is the opposite of what I see, because in the equation it's negative h, or the opposite of h. So my h value is really going to be a -5 instead of that +5. My a value is going to be 1, right? I don't see a number out in front, but that whole expression is multiplied by 1. If I made it a 0, I would no longer have a quadratic, right? It would just be a flat line. So I have an h value, the opposite of the 5, and my k value is what I see, which means I have a vertex then at -5, -7. My A value is positive, so that's going to control the direction of my opening. It's a smiley positive parabola, so it's going to open up, and that H and K dictate my transformation, right? So it's going to move the graph. And if you're ever confused, just graph it on your calculator, right? I see, if I type that in, I see my vertex here at -5, -7, right? So you can kind of work backwards on the whole AHK by graphing. I see that transformation there, that the vertex moved from 0, 0 to -5, -7. So my description of the transformation then would be left 5 for the -5, right? And then down 7 for that -7 for the K value. Number 10, same thing. AH and K, I have that negative out in front. So I'm going to have an A value of just -1. That's going to flip my graph, right? Make it a frowny parabola. And then H is opposite of what I see. So I see a -3, so my H is going to be +3, and my K value is going to just be 2, right? I don't need that plus, so let's get that out of there. So just 2, right? So I have a vertex then at 3, 2. Get that graphed out. I need some other data, so I'm going to type that into my equation editor, or y equals negative x minus 3 squared plus 2. Go to graph, get a sneak peek. I see that downward frowny. I'm going to go to table to get some values that I need. I know I have a vertex at 3, 2. There it is, right? And then I see that symmetry. So I see data at 2, 1 and 4, 1. And that's really enough data to get my graph that I need for this problem. So I'll do my best to connect it with a nice smooth parabola. For 11, we have a t-shirt company plans to sell t-shirts. They gave them the equation P for profit equals -x squared plus 60x minus 100, where x is the number of shirts and P is the profit. And so we're asked to determine where we see that maximum profit, how many shirts will give maximum profit, and then determining what that maximum profit will be. So we're going to enter that equation into an equation editor to see if we get a nice clean graph, which on here TI, right, we don't get a very good graph at all. The zoom fit option, not a whole lot better at all, really. Doesn't give us anything useful. So going to just go to table. I'm going to try to scroll. I see at 0 shirts, I lose $100, but then I start to see a profit as I sell more and more shirts. I know this profit is going to maximize somewhere because it's a parabola equation. See right here at 30 shirts, I maximize my profit at $800, which is a pretty lousy business model. But the number of shirts to give maximum profit would be 30. And then that's going to give me a maximum profit of $800. For part C, determining the range where we see positive profit. A lot of scrolling involved here, which makes the TI not the best probably for this problem. But I'm looking for where I get a positive profit, right? We don't want to lose money as a business. So if I go to second table set, I can restart my table at 0, right? So I enter 0, go to second table again, and I see at 1 shirt I lose $41, but there at 2 shirts, that is where I begin to turn a profit, right? So I know that is the first value in that range. right, 2, and then I have to do a bunch of scrolling again to see where my profit maximizes. I know that's going to be coming up here at 30, and then it's going to start to fall off again, right? So there goes where my profit starts to fall. And as a business owner, I don't really want to sell this number of shirts because I'm losing money, right? If I'd have stopped at 30 shirts, I would have maximized. And then right here at 58 shirts, that is the last time I see positive profit. And anything more than that, I start to go into negative profit again, which no business would want to do. All right, throwing a ball from 6 feet above the ground, Mark throws a ball upward. The height of the ball t seconds after the ball is thrown is given by the equation h equals negative 16t squared plus 8t plus 6. So I'm going to enter this into the equation. The negative 16t squared represents my gravity. The plus 8t is me Mark throwing the ball upward. And then the plus 6. Right, so we need to determine maximum height, time that it takes to throw the maximum height, and then when the ball hits the ground. I'm going to go to Zoom 6 to reset my graph, and I see the ball is actually off the ground for a very short time. Right, so the graph here is not the best. It needs to be a little more zoomed in. I'm going to go to table. My table is all messed up from the previous problem. So I can go to Zoom, second table set and enter 0, or you can always just reset your calculator between each problem. Right, so at 0 seconds, I'm 6 feet above ground. So that's the height before the ball was released was 6 feet. At 1 second, then, it's already down back below ground by 2 feet, so it would have already hit the ground. So my TI here is not super helpful. I can try various things to try and get better information. I can try to trace. I see it about right here between 0.21 and 0.4 seconds. It maximizes at about 7, right? And then it drops back down to the ground here close to 1 second, right? So I'm not getting super accurate data from this graph. I can do my best to scroll, but I'm not getting accurate enough data because it says determine. I can try saying about so many seconds. So I see that it reaches its max height of about 7 feet. And that takes place at about 0.2 seconds. If I need more accurate data, I'm going to have to use some better tools or switch over into Desmos. It reaches the ground then at a little less than 1 second, so I could say about 1 second. Switching over to Desmos here, I can type that equation back in on Desmos. So there's negative 16t squared plus 8t plus 6. The nice thing about Desmos is I can click on the highlight points, right? That vertex, that maximum takes place at 0.25 seconds, which is about what we said and 7 feet. And then we see that it hits the ground, right? It goes back to a Y value of 0 at 0.91 seconds. So we were pretty close on our estimates, but Desmos gives you a quick way to get to a more accurate solution. So looking at this problem, function there, h of t equals negative 16t squared plus 110t plus 72. Models the height h in feet above the ground, t seconds after being launched straight up in the air. What does the number 72 represent in the function? So that negative 16t squared, that's got to be gravity, right? Pulling something back towards the ground. And then the plus 110 is that upward thrust or force The 72, right, we have some options: initial height, max height, initial speed, or max speed. If you don't just know these things, you may be best to, on SAT, go into Desmos and type it in, right? If I try typing it into my TI-83, I don't get a very good picture. So let's just go into Desmos here and get that typed in. Let's clear out old data. 16, negative 16x squared plus, what is it, 110? Yeah, 110x plus the 72, right? And I'm going to have to adjust my zoom here a little bit. If I hit home, that just puts me back there. So I can pinch and squeeze kind of different directions, stretch. I don't want to stretch this x-axis anymore, but I can see here that 72, 0, 72. Well, what does that mean? So after 0 seconds, my object is already 72 feet above the ground. Right? So that tells me then that I have that initial value of 72 feet. So that would be answer choice A. So when in doubt, graph it. On SAT day, when in doubt, using Desmos. That brings us to the end. Test coming up, so be ready for that.